In this experiment, I will try to calculate the inductance of an RL circuit with AC voltage using a setup as shown in this figure. I'll connect the circuit elements on a breadboard and measure the voltage across the inductor. The potential difference across the inductor is related to the inductance as in the formula shown. By integrating this equation, we obtain the following relation, and we see that the ratio of max voltage to max current is constant. This ratio is called the inductive reactance of the circuit. Now we have to find the current to find L. To calculate the current, I will find the voltage across the resistor. For this, I will use the Pythagorean theorem since there is a phase shift of 90 degrees between the AC power supply voltage and the inductor's voltage. After finding the resistor voltage, we can find the current flowing through the circuit using Ohm's law. Now that we can write the current in terms of known values, we can go back to the formula for inductive reactance. To find L, we divide the equation by omega, and since we know the frequency of the voltage supply, we obtain the following result. In my experiment, I chose the peak voltage as 4 volts and the frequency as 500 kHz. I picked 5 resistors. I chose the inductor to have 8.2 microhenry inductance, which I will use to calculate error later on. I formed the circuit as shown here. First, I connected jumper cables to the power supply. I connected the hot wire, then the resistor with 100 ohms resistance, then the inductor, and the ground. To make the measurements, I connected the oscilloscope with its ground connected to the ground, and the probe to the other end of the inductor. This completed my circuit. I auto-tuned the oscilloscope to show me the voltage in correct amplitude. For each of my measurements, I simply removed the resistor on the breadboard and replaced it with another one. For 100 ohms, the measured voltage was 900 millivolts. For 120 ohms, it was 740 millivolts. For 150 ohms, 680 millivolts. Next, for the 330 ohms resistor, I measured 320 millivolts. And finally, for the 470 ohms resistor, the oscilloscope showed 240 millivolts. For each measurement, I calculated the current as in this table. I plotted the graph of this table and obtained a linear relationship as expected. The slope gave me the inductive reactance, and dividing it by omega, I got the experimental inductance result, which was 6.758 microhenry. Using the percent error formula, I found the error of my experiment as 17.56%. The main reason for this error may be that the breadboard is malfunctioning since I obtained very different results when I formed the same circuit on different parts of the board. I had to compare my voltage measurement results with LT-SPICE simulation results to ensure that there were no problems. Here are the screenshots of the simulations. The other causes of error might also be the resistance of the wires, the small inductance of the resistor, the heat increase changing inductance and resistance, and the noise from the outside which interfered with the AC signal. Overall, it can be said that the inductance can be calculated by only measuring the voltage across the inductor with acceptable error. However, the equipment must be tested thoroughly to ensure that there are no malfunctions.